In this video, we'll go over the 2025 AP Computer Science A FRQ 1A. This question involves dog walkers who are paid through a dog walking company to take dogs for 1-hour walks. A dog walking company has a varying number of dogs that need to be walked during each hour of the day. A dog walking company is represented by the following dog walk company class. All you need to know here is that the dog walk company has a method that tells you the number of dogs it has available to walk in a given hour, represented by num available dogs, and a method that updates the number of dogs available to walk, represented by update dogs. A dog walker is associated with the dog walking company and is represented by the dog walker class. This just lays out a private max dogs member, which is the number of dogs the walker can walk in any given hour. It also lays out a reference to the company that the dog walker is associated with. It has a constructor that just sets the members we looked at, and then the two methods we will implement for 1A and 1B. Write the walk dogs method, which updates and returns the number of dogs this dog walker walks during the time specified by hour. Values of hour range from 0 to 23 inclusive. A helper method, num available dogs, has been provided in the dog walk company class. The method returns the number of dogs available to be taken for a walk at a given hour. The dog walker will always walk as many dogs as the dog walking company has available to walk, as long as the available number of dogs is not greater than the maximum number of dogs that the dog walker can handle, represented by the value of max dogs. Another helper method, update dogs, has also been provided in the dog walk company class. So that multiple dog walkers do not sign up to walk the same dogs, the walk dogs method should use update dogs to update the dog walking company with their number of dogs this dog walker will walk during the given hour. The parameters of the update dogs method indicate how many dogs this dog walker will walk during the time specified by hour. For example, if the dog walking company has 10 dogs that need to be walked at the given hour, but the dog walker's maximum is 4, the update dogs method should be used to indicate that this dog walker will walk 4 of the 10 dogs during the given hour. As another example, if the dog walking company has 3 dogs that need to be walked at the given hour, and the dog walker's maximum is 4, the update dogs method should be used to indicate that this dog walker will walk all 3 of the available dogs during the given hour. The walk dogs method should return the number of dogs to be walked by this dog walker during the time specified by hour. Okay, now that we've read all that, what are we doing? We're writing the walk dogs method that represents the one walker walking an amount of dogs in an hour. First, we'll write ourselves a variable for the number of dogs available. So, int dogs av equals company, which is our member that links us to a certain company, dot num available dogs at the hour that's passed into this method. Next, we'll set up a variable for the number of dogs that end up being walked. So, int dogs walked equals 0. Like we read in this first example, if there's more dogs available than what our max is, we just walk our max. So, if dogs av greater than or equal to max dogs, then dogs walked equals max dogs. Else, meaning if the company has less available than what our max is, then we just walk the number that is available. So, dogs walked equals dogs av. Next, we must call the update dogs method because the question told us to. So, company dot update dogs of the hour passed into this method and dogs walked. Finally, we will just return the number of dogs we walked. In this video, we'll go over the 2025 AP Computer Science A FRQ 1B. Write the dog walk shift method, which performs a dog walking shift of the hours in the range start hour to end hour inclusive and returns the total amount earned. For example, a dog walking shift from 14 to 16 is composed of 3 1-hour dog walks starting at hours 14, 15, and 16. For each hour, the base pay is $5 per dog walked, plus a bonus of $3 if at least one of the following is true. Max dogs are walked, or the walk occurs between the hours of 9 and 17 inclusive. I won't bore you with writing out the table. Let's just jump into writing the code. We are writing the dog walk shift method. To start, we'll give ourselves a salary variable, so in salary equals 0. Next, we'll loop through every hour of our shift, so for in I equals start hour, I less than or equal to end hour, I plus plus. Inside the loop, we'll make a dogs walked variable that's an integer, so in dogs walked equals. This will equal calling the walk dogs method from 1a with the current hour. So, walk dogs of I. After that, we'll determine our bonus. If the number of dogs walked is equal to our max number of dogs, so if dogs walked equals max dogs, or is the current hour is between 9 and 17, so or I greater than or equal to 9 and I less than or equal to 17. Inside the condition, we give ourselves the extra $3. So, salary equals salary plus 3. Outside the condition, we add on our per dog walked salary. So, salary equals salary plus 5 times the number of dogs walked. Finally, outside the for loop, we return salary. So, return salary. In this video, we'll go over the 2025 AP Computer Science A FRQ2. This question involves the sign text class, which contains methods that are used to include a signature as part of a string of text. You will write the complete sign text class, which contains a constructor and 2 methods. The sign text constructor takes 2 string parameters. The first parameter is a first name, and the second parameter is a last name. The length of the second parameter is always greater than or equal to 1. The getSignature method takes no parameters and returns a formatted signature string constructed from the first and last names according to the following rules. If the first name is an empty string, the return signature string contains just the last name. If the first name is not an empty string, the return signature string is the first letter of the first name, a dash, and the last name, in that order. The addSignature method returns a possibly revised copy of its string parameter. The parameter will contain at most 1 occurrence of the object's signature, at either the beginning or the end of the parameter. Return string is created from the parameter according to the following rules. If the object signature does not occur in the string parameter of the method, the return string is the value of the parameter with the signature added to the end. If the object signature occurs at the end of the string parameter, the return string is the unchanged value of the parameter. If the object signature occurs at the beginning of the string parameter, the return string is the value of the original parameter with the signature removed from the beginning and appended to the end of the parameter. Don't worry if you didn't understand some parts of that. Now we'll get to the code. I've already written out the public class sign text. Hopefully you got at least that far when you took the exam. First, let's set up our members. So, private string fname and private string lname. Next, we'll make our constructor. So, public sign text takes in the parameters of string fn and string ln. Inside, we do fname equals fn and lname equals ln. Next, we'll do the getSignature method. Public string getSignature. If the first name is empty, so if fname dot equals the empty string, then just return the last name. So return lname. Otherwise, return the first letter of the first name followed by a dash followed by the last name. So return fname dot substring of 0 and 1 plus a string dash plus last name. Last, we'll do the add signature method. So, public string add signature that takes in a string param that I simply called param. I didn't want to call a getSignature a bunch, so I start off with doing string sig equals getSignature. First, if the signature occurs nowhere in the parameter, then we simply append the signature onto the end of the parameter. So, if param dot index of sig equals -1, then return param plus sig. Next, if the signature occurs at the end of the parameter, then just return the parameter. So, if param dot index of sig does not equal 0, then return param. Finally, if the signature occurs at the start of the parameter, then we want to move it from the front to the back. So, if param dot index of sig equals 0, then string temp equals param dot substring of sig dot length. So this temporary string represents the parameter without the signature part. Finally, we return temp plus the signature part, so return temp plus sig. In this video, we'll go over the 2025 AP Computer Science A FRQ 3A. This question involves pairing competitors in a tournament into one-on-one matches for one round of the tournament. For example, in a chess tournament, the competitors are the individual chess players. A game of chess involving two players is a match. The winner of each match goes on to a match in the next round of the tournament. Since half the players are eliminated in each round of the tournament, there is eventually a final round consisting of one match and two competitors. The winner of that match is considered the winner of the tournament. Competitors, matches, and rounds of the tournament are represented by the competitor, match, and round classes. You will write the constructor and one method of the round class. We'll skip through all this provided code as I'll point out what's necessary when it comes up. Write the constructor for the round class. The constructor should initialize competitor list to contain one competitor object for each name in the string names. The order in which competitor objects appear in competitor list should be the same as the order in which they appear in names, and the rank of each competitor is based on the competitor's position in names. Names are listed in order from the best ranked competitor with rank 1 to the worst ranked competitor with rank n, where n is the number of elements in names. Again, we'll skip this example and go straight into the code. We're writing the constructor. We want to loop through the names list, so for in I equals 0, I less than names.length, I plus plus. Next, we'll give ourselves a temp competitor, so competitor C equals new competitor. The competitor takes the arguments of the current name and one more than the current loop counter value, so names sub I and I plus 1. Finally, we add the competitor to the competitor list, so competitor list dot add of C. In this video, we'll go over the 2025 AP Computer Science A FRQ 3B. Write the round method build matches. This method should return a new array list object by pairing competitors from competitor list according to the following rules. If the number of competitors in competitor lists is even, the best ranked competitor is paired with the worst ranked competitor. The second best ranked competitor is paired with the second worst ranked competitor, etc. If the number of competitors in competitor lists is odd, the competitor with the best rank is ignored and the remaining competitors are paired according to the rule for an even number of competitors. Each pair of competitors is used to create a match object that should be added to the array list to return. Competitors may appear in either order in a match object, and matches may appear in any order in the returned array list. Like usual, I'll skip through the examples and go straight to writing the code. We are writing the build matches method. To start, we'll initialize a matches array list. So, array list of matches equals a new array list of match. If the competitor list is even, so if competitor list dot size modulus 2 equals 0, then we will do one particular method. I'm going to do a 2-finger / 2-pointer method. I'll give myself an index into the front, so in best equals 0. I'll also give myself an index into the back, so in worst equals competitor list dot size -1. We're going to loop while best is strictly less than worst, so while best is less than worst. We will do stuff. Inside the loop, we will set up a match object. A match object just takes two competitors, where the order you pass them to the constructor doesn't matter. So, match temp equals a call to the match constructor. To the match constructor, we will pass the best and worst competitors. So, competitor list dot get best and competitor list dot get worst. Now that we've made our temp match, we will add it to the array list. So, matches dot add temp. Finally, we'll move up best by 1 and move back worst by 1. So, best equals best plus 1 and worst equals worst minus 1. Next, we'll handle the odd number of competitors case. The exam doesn't dock you for writing inefficient code as long as you're using their helper methods. So we're going to rewrite much the same code. Else, so implicitly, if the number of competitors is odd, then we will start best at 1 and worst at the end. So, int best equals 1 and int worst equals competitor list dot size minus 1. We can literally copy and paste the rest of the code because it will all be the same. After both of the conditions are done, we return matches. In this video, we'll go over the 2025 AP Computer Science A FRQ 4A. This question involves reasoning about a number puzzle that is represented as a two-dimensional array of integers. Each element of the array initially contains a value between 1 and 9 inclusive. Solving the puzzle involves clearing pairs of array elements by setting them to 0. Two elements can be cleared if their values sum to 10 or if they have the same value. The puzzle is considered solved if all elements of the array are cleared. You will write the constructor in one method of the sum or same class, which contains the methods that manipulate elements of the puzzle. Like usual, I'll skip through all this code they give you. Write the constructor for the sum or same game class. The constructor initializes the instance variable puzzle to be a two-dimensional integer array with a number of rows and columns, specified by the parameter numRows and numCols respectively. Array elements are initialized with random integers between 1 and 9 inclusive, each with an equal chance of being assigned to each element of a puzzle. When an element of the two-dimensional array is accessed, the first index is used to specify the row, and the second index is used to specify the column. Now, let's jump into the code. Okay, I have the method header set up right here. First, we have to initialize the puzzle member. So, puzzle equals new 2D integer array whose row dimension is numRows and whose column dimension is numCols. Next, we'll do a nested for loop to initialize the numbers in puzzle. So, for int I equals 0, I less than numRows, I plus plus. In the inner loop, for int j equals 0, j less than numCols, j plus plus. On the inside, we want every number to be a random integer between 1 and 9. So, puzzle sub I sub j equals, cast the output to an int, parentheses, math.random times 9 plus 1. This fills every slot with a random number between 1 and 9. In this video, we'll go over the 2025 AP Computer Science A FRQ 4B. Write the clear pair method, which takes a valid row index and valid column index as its parameters. The array element specified by those indices, which has a value between 1 and 9 inclusive, is compared to other array elements in puzzle in an attempt to pair it with another array element that meets both of the following conditions. The row index of the second element is greater than or equal to the parameter row. The two elements have equal values, or have values that sum to 10. If such an array element is found, both array elements of the pair are cleared, set to 0, and the method returns true. If more than one such array element is found, any one of these identified array elements can be used to complete the pair and can be cleared. If no such array element is found, no changes are made to the puzzle, and the method returns false. Like always, we'll jump right into the code. Let's start out with giving ourselves a variable representing the element we compare to the other elements. So, in E1 equals puzzle subrow subcol. Next, we're going to do a bit of a tricky thing. Based on the problem statement, we will at one point end up going over the element we are comparing the other elements to. Obviously, we don't want that to happen because that element will equal itself, and then the only element we will clear out is a given element, not a pair of elements. So, my trick is, right now set the given element to -1, and then at the end we'll put it back. Since -1 can't equal the numbers 1 through 9, and it can't sum with another number to equal 10, the code will just implicitly pass over this element. So, puzzle subrow subcol equals -1. Next, we'll set up the loop. For in I equals row I less than puzzle.length I++, for the inner loop, we will do for int j equals 0, j less than puzzle sub 0 dot length j++. Inside the inner loop, let's get the current element. So, in cur equals puzzle sub I sub j. If E1 equals the current element or sums to 10 along with the current element, so if E1 equals cur or E1 plus cur equals 10, then we'll do stuff. If we're inside this condition, we found two pairs that match. So, set the current location we're at to 0 and set the original location to 0. So, puzzle sub I sub j equals 0, and puzzle sub row subcol equals 0. Finally, we return true because it's true that we have found and cleared a pair. On the outside of both loops, we would only reach here if we found no pairs, so we want to do two things here. First, let's reset the dummy value we set at the start. So, puzzle subrow subcol equals E1. Last, we return false because we found no pairs to clear. Like and subscribe to learn more.